Hello guys, so in this video we are going to discuss the solution of the problem minimize the height 2. Okay, so let us look at the problem statement. So the problem statement says that we are given an array ARR denoting heights of n towers and a positive integer k. Okay, so there is an array ARR which denotes height of n towers. For each tower you must perform exactly one of the following operation and exactly one. So what can we do? We can either increase the height of the tower by k or we can decrease the height of the tower by k. Okay. So one of these two operations are to be performed on the height of the tower. Now the objective is, having done so, find out the minimum possible difference between the height of the shortest and tallest towers after you have modified each tower. Okay. So let us take the example. So in this particular case, the size of array is 4, which is 1, 5, 8, 10, and k equals to 2, and so essentially I can increase the height by 2 or I can decrease the height by 2. And then if you see that, this is how an optimal array can be formed, such that the difference between the largest being 8 and the smallest, which is 3, is 5. So thereby 5 is the answer. Okay. So having understood the problem statement, let us look at the solution for it. Okay. So first let us look at the brute force solution for this, and then we will go ahead and explore the optimal solution as well. So the brute force solution is pretty simple. So which is what? So we are given an array here, and let us say the array is basically this. It contains of 3, 5, 8 and 10. So this array is given to us, and what we can do is basically we can either add k to it, each of the elements, or we can subtract k from it, and here the value of k is 2. So the brute force solution is basically what we will do is that we will go ahead and generate all possible arrays here. What do I mean by this is basically, so here the size of the array is 4, and each of the elements of the array has at most 2 options. So then the total combination will be 2 to the power 4, right, which is 16. So essentially what I am trying to say is, if 3, 5, 8, 10 are the arrays, so okay, so I'm not going to write down all the 16 combinations, but just to have the point clear, so 3, 5, 8 and 10. So what we can do is basically here we can subtract 2 from all the elements. So which is what, like if you subtract 2 from it, this becomes 1. This is what, 5, 2, 3. This becomes 8 minus 2 is 6, and 10 minus 2 is 8, right? And then this becomes what, 5, 7, 10 and 12, right? So this is plus, and here we are performing negative operation. So one such array, so generate all possible arrays. So one such array would be, let's say, ARR1, and this will be basically 1, 3, 6 and 8. Another array could be 5, 7, 10 and 12, and there are various other arrays are as well, like so for instance, another array could be the crisscross between these two, right? So what I meant to say is like 1, 7, 6 and 12. So these are all possible arrays which can be generated. So similarly, if you go ahead and generate all possible arrays, there that will be 2 to the power 4, which is 16. So 16 such subarrays can be generated. Once you have 16 such subarrays, what we will do is basically we will compute the smallest, or we will find out the smallest and the largest value in that particular subarray. So for instance, let us say this is one such subarray. I'll take the smallest. So the smallest value here is 1 and the largest value here is 12. Okay, and the difference between this is what, 12 minus 1, which is 11. So 11 can be obtained from this particular array. Similarly, there would be other arrays. So for instance, here from here 8 minus 7, so 7 is what we can obtain from here, right? Similarly, from here the highest is 12 and the lowest is 5, so 12 minus 5 is 7, so 7 can be obtained from here. Okay, so similarly there will be various, so for each generated array we will find out this value, which is the minimum, which is the difference between the largest and the smallest tower. Okay, and so that, let us say that value is being stored in some set S. Okay, so like 7 is there, 7 and 11, and what we need to do is, our answer basically is to minimize that height. So basically answer is minimum of set S. Okay, so that is how the brute force solution works. Okay, now let us analyze the running time complexity. So the running time complexity is pretty simple, which is like order of 2 to the power n, because we have to generate all possible arrays over there, right? And the running time complexity will be determined by that. So that's about the brute force solution. So let us now look at the optimal solution. So before we begin with the optimal solution, let us study the problem and break down the problem into its simpler form. Okay, so in order to do so, let us say that array is given to us, which is like 3, 5, 8 and 10 is given to us, and we want to find out the minimum difference of height between two towers, right? So since we have to operate on two towers, so we either, the minimum difference could be obtained via these two towers, or can be obtained via these two towers, or can be obtained via these two towers. Okay, similarly the other towers would be 5, 8 and 5, 10. Okay, and the last pair is 8, 10, right? So if we go ahead and analyze all these pairs, and here for now we will forget about that we either have to increase or decrease it. It's just that, let us say the array is given to us and which contains the height of the tower, and we want to find the minimum difference of height between the towers. Okay, so if you want to find out the minimum difference of height between the towers, we have to generate all possible pairs over there, and we need to compute the difference between them, right? So here we have computed all the difference, and the minimum one is what will be our answer. So for instance, in this particular case, here the value, the difference will be 2, here the difference is 5, here it is 7, here it is 5, here it is 3, and here it is 2 again, right? So the answer for this, or the minimum height, right, the minimum value will be 2 here, right? So we understand that in order to solve this problem, we have to generate all possible pairs rather than generating all possible sub-arrays or all possible arrays. We just have to generate all possible pairs and operate on it in order to get the minimum height. Okay, so that portion we understood. Now let us see if we can further optimize it. Well, a further optimization is possible here, and the further optimization relies on the property of array, property of a sorted array, right? So let us say the array which was given to us, we go ahead and sort that array. Okay, so let us say the array, so in our case the array was already sorted, but let us say if the array was not sorted, we sort that array, and now we got the tower's height in this format, right? So here we have sorted the array. Okay, and let us now write down the pairs here. So the pairs were 3, 5 and 3, 8 and 3, 10. Okay, and similarly here the pairs are 5, 8, 5, 10, and here the pairs are 8 and 10, right? So these are the 6 pairs which we have. Now let us say if we compute this, let us say this. Okay, let me use a different ink for this. So let us say we compute this, right? Do we really have to compute these two pairs? Okay, remember here the one element is known to us, which is 3, right? The element 3 is fixed here. right? And the other element, which is this element, right? This is, let me use this is increasing, right? Initially it was 5, then it becomes 8, and here it becomes 10, right? So since it is increasing, the difference between the pairs will also increase, and that is what we can see here also, like 5 minus 3 is 2, whereas here it will be 5 and here it will be 7, right? And since our objective is to find the minimum element, thereby we don't really have to operate on these pairs, right? Similarly, if you see this here, the difference is what? 3, and we don't really have to operate on this because we know that for a fact that this difference will be greater than this difference, right? Similarly, here the difference will be 2, and if at all other elements or other pairs were there, then we don't really have to operate on those pairs. Okay, so we understand that we just have to, so what do we see from here, right? So what, whose difference are we computing? 3 and 5, 5 and 8, and 8 and 10. So if you see here, 3 and 5, this difference we are computing. 5 and 8 we are computing, and 8 and 10 difference we are computing, right? So, and the other pairs difference we are ignoring it altogether. Okay, so what I was trying to tell you from here is, if you sort the elements of the, if you sort the array, then we don't really have to go ahead and compute all the pairs. We can just get our answer, or we can get our minimum height by just comparing the adjacent element. So we don't have to, so from here the takeaway is basically, we don't have to, we just have to compare or compute, whatever you'd like to call it, compare adjacent element, right? Adjacent element. All right, so let us say we understood this. So we understand that, okay, we will go ahead. So the first thing we are going to do is that we will first sort the array which is given to us. Once we have sorted the array, then we will go ahead and concentrate only the pairs. If I am at index I, then I'm just interested in I and I minus 1. That's it. Similarly, if I am at index here, then I'm interested only in these two pairs. Okay. So that's about one concept which we needed to understand. Now let us look at another concept which will be used in this. So the other concept is basically, let us say the array is sorted. So now the array is already sorted for us, and let's say the elements over there are A, B, C, and D. So these are the 4 elements which are present. Now we know that D is the max element of the array, right? Since the array is sorted in increasing order, so D is maximum. Similarly, A is minimum. We already know that. Okay. Now what we can do is basically, we can go ahead and add k to it, or we can go ahead and subtract k from it. So we can increase or decrease the height, right? So similarly here also we can go ahead and increase and decrease the height. So now let us say we are, or we don't really have to worry about A and D. Let us say we are taking any two adjacent pair, right? A and B we are taking up, right? And our objective is to minimize the height, okay, I'm so sorry, minimize the height difference, right? Height difference by performing the operation, which is to increase or decrease. So now let us go ahead and perform the operation, which is like plus k or minus k. Here also plus k or minus k. Okay, so what we can do is, and we know that B is greater than A. So what we can do, so let's go with the 4 combinations which we can get. So the first pair would be A plus k and B plus k. Okay, so that will be our first pair, right? The second pair will be our A plus k and B minus k, right? Similarly, the third pair will be A minus k and B plus k, and the final pair will be A minus k and B minus k. Okay, Now let us say if, so here basically what it means is that tower A height I am increasing by k, here tower B height I am increasing by k, right? In this particular scenario, I am increasing the height of tower A by k, whereas here I am decreasing the height of tower by k. Okay, so given these scenarios, if we try to find out the difference between pair A and B, what we will get is that basically B plus K minus A plus K, right? This is equals to B minus A, right? Similarly here, if you go ahead and do it, so this is B minus K comma A plus, this thing. So this will be basically B minus A minus 2K, right? Similarly, let's solve this, which is B plus K minus A of minus K. So this will be B minus A plus 2K. Okay, let's put B minus A in common, and here it will be B minus K minus A minus K, right? So this will be B minus A. So here if we increase both or if we decrease both, that will not give us the answer. So this we can ignore it, we can cross it. This is just B minus A. So of these four pair, which will give us the minimum value, right? So this will give me the minimum height. So in a sense, what I was trying to say here is basically if my pair is A and B, right? A and B, and I want to minimize the height, right? So what I need to do is basically so let's go up, let's see this, what we had to do here in order to obtain this. I have to add k to A and I have to subtract k from B. So let us add k and delete here, and that is how we will be able to minimize the height. Okay, so all the pairs which were here, which we were discussing, right? So first optimization, we saw that we don't really have to operate on all the pairs. Okay, so we just have to operate on this pair. Okay, and the second optimization we saw there is even the I don't really have to go ahead and explore all possible four combinations. So this ideally will have four combinations, right? Plus and minus for both sides. So four combination here. So from the maths, we saw that we don't really have to go ahead and explore all the four combination. We can just rely on one combination, which is to increase this by k, and decrease this by k, right? And we will get our answer. Okay, so I hope the second concept is also clear. Okay, and if that is not clear, it makes a lot of sense graphically. So let us say, a graph is given, this is a graph, this is basically height. I'm so sorry, this is tower. So tower 1 2 3 and so on. So this is tower, and this, let's say, represents height of the tower. Okay, and let's say and since the array we have already sorted it, so we know that this is like this, and this will be bigger, and similarly the other element will be bigger than this, and so on, right? We get that, right? So let us say there are, we are analyzing these two pairs. Okay, let us say, for instance, we are analyzing these two pair. Okay, so if I want to minimize the height between these two, then naturally I have to increase this. Okay, I have to increase this portion, and I have to decrease this, right? Then only the height between these two will be minimized. Okay, and that is what, so this is the geometric interpretation, and that is what the maths also suggest us, right? This is the maths behind it. Okay, so I hope both the concepts are clear. Now let us apply both the concept and try to get to our solution. Okay, so let me summarize it one more time. So first optimization was, let us sort the array, right? Sort the array. And why we were sorting the array? Well, the reason for sorting the array was basically so that we don't really have to operate on all the pairs. We just need to operate on adjacent pairs. Okay, so that was the point of sorting the array, adjacent pairs. Okay, so that was one optimization. The second optimization was basically, when we are operating on pairs, what we need to do is we have to, so let us say this is one pair on which we are operating on. So what we need to do is that in order to minimize the height, I have to increase a by k and I need to decrease b by k. Okay, and remember, this is to this is to minimize it, right? So these are the things which we will do while iterating on the pairs. Okay, so there is one last thing which we have to add and which we need to understand, and then we will jump to our coding part, which is like the minimize height will not be obtained just by deducting, just by calculating the difference between these two pairs. Okay, we also have to take into account that when I am operating on, or when I am performing a plus k, or when I am performing b minus k, at that time what is the maximum element which could be there, or what is the minimum element which could be there. When we have manipulated a comma b to a plus k and b minus k, then we don't know what is the relationship. Now we don't know what is the relationship between a plus k and b minus k, right? And what I meant to say is that we don't know which one is lesser and which one is greater. Okay, that we don't know. Okay, so that is one part we need to understand. So what we have to do is basically, okay, so let's say that the array was basically, some array was given to us and we are operating on pair AB, right? And this is the array which was given to us, and let's say, and we know that this array is sorted. So C is the minimum element and D is the maximum element. C we know to be a minimum element and D we know to be a maximum element. Okay, now the height, now, so the manipulation, now we have to manipulate this array. So let us manipulate this array. So let's say since we are operating only on this, so the manipulation will be done on the basis of this, which is a plus, this a will become a plus k and b will become b minus k and d, right? Okay, so after doing this, so from this array we know d is maximum, c is minimum. Now what we have done is basically we have added a k to a. So now it might be possible that a plus k is greater than d, right? So that is why when we have to compute the height, right, this will be equals to maximum of d minus k. I'll come why I'm subtracting k from d, comma a plus k. Remember, a plus k, not b minus k, right? Because b minus k is basically we are reducing b by k, so naturally it will be less than d. Here we are adding k to it, so it might be possible that it becomes greater than d. Okay, so that is one. And the second one is basically, so the height was what? Maximum of this and minimum of this, right? So, and what is the minimum here? Well, the minimum we know is C, right? And C plus K, again, D minus K and C plus K, I'll explain it, B minus K here, right? Okay. So I hope at least this is clear, that why here we have, when we are computing max, why A plus K is there, whereas when I'm computing min, right, this is min, B minus K is there. Okay, so I hope that part is clear. Now let us look at why I have used D minus K and C plus K instead of D and C, right? So see, first we have to manipulate the array, right? That is given in the question, that we have to manipulate the array. We cannot use D as such and C as such. So we have to manipulate the array. So that part is understood. Now, if we have to manipulate the array, then we can either increase the height or decrease the height, right? Now let us say if I increase D, instead of using D minus K, if I use D plus K, if I use D plus K, then the difference between the height will maximize, right? And our objective is to minimize. Since our objective is to minimize, thereby rather than using D plus K, I have used D minus K. Okay. Similarly, in the case of minimization, C minus K will minimize things, right? C minus K will reduce the height, because of which the difference will increase, right? The difference will maximized, right? Because of which we are using C plus K rather than C minus K. Okay. So let me sum up all these things. I know it's bit, you know, uh, it's a bit tricky to understand. So let me, explain it finally. So what we will do is we will sort the array. Okay. Then what we are going to do is iterate on adjacent pairs. Okay. Then now let us say there is some pair A comma B. The height is basically max of A dash. I'm calling it A dash because A dash is a manipulated array, and let's say A was given to us, min of A. Okay. And what is the value of max of A? Remember, this max of A is basically like with respect to A comma B, right? This will change when we will go with respect to C comma D. Okay. So the max is basically here max of, remember, max of array A, right, minus K, comma, see this, let's say this is pair A comma B and we are at ith position. Okay. Okay. And let's do this, right, rather than being this way, right, rather than using A prime and all those things, right, I can just write it down HT, right? So if I am at height I, then this is basically equals to, so this portion is fine, max of A minus max. Okay, let me use this instead. Let me write it down like this, max of, so we are at ith, so see this D minus K, right? What is the, sorry, A plus K, right? Here we were using A plus K. What is A? So if we are at ith, then minus 1, right? So this is basically A minus 1, and what is what? This is plus K, and we know that the last element minus 1 minus K, right? Minus minimum of A of I minus K and A of 0, since A of 0 is the minimum element, plus K, right? So this is what the thing will be, and then the max height is basically max height is basically max of height comma max height. Okay. Okay, so that's about the explanation, folks. Now let us jump to our coding section. So I've already coded it, and it's, well, the code is pretty simple, right? So we have sorted the array, and this is just for initialization. We have initialized it, so the delta we will get is the last element minus the first element, and then we computed write this, the minimum element and the maximum element as per our understanding. Once I have computed the maximum and minimum, then I have subtracted it, and this is basically the the minimum difference is what I'm maintaining in answer, and I'm returning answer. There is this condition I did not talk about in during our discussion, but in the question it is clearly mentioned that if the difference between ARR I minus k, if ARR minus k is less than or equals to 0, then we don't really have to operate on it. So that is why we are skipping it. Okay, so that's from the coding section. Now let us submit the solution. Okay folks, so our solution got accepted. So that's about the video folks. If you have any questions or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.